You get the idea. We are just reading off all these examples since adaptation is very much local, and you have to just remember the lessons as best as you can and see what's of interest for further details for you and what you may be involved in implementing and so on. Chapter 14 is looking at small-scale solar solutions for energy resilience in Bangladesh. So key messages here: solar home systems, SHSs, offer cost-effective, climate-friendly alternative power source in off-grid communities. SHS serve both climate adaptation and mitigation as a win-win solution. We talked about these before. There are opportunities for SHS to accomplish multiple sustainable development goals as co-benefits, power access, early warnings, education, health, etc. are all served by this. Innovative strategies can be developed to make SHS more accessible and equitable in rural communities. Local energy, local grid, we talked about this a little bit in this series of podcasts as well as elsewhere. So here is a trail magic in Oberlin, Ohio, USA, with a 5.2 kilowatt solar system, and a solar home in Batiagata, Bangladesh, with a 40 watt solar system. So this is a thatched hut doing its thing, and this is a tiled or whatever kind of solid structured roof which has got rooftop solar as well. So it's a nice contrast from one rural area in Ohio to a rural area in Bangladesh. I think Oberlin is a small town, farm country, if I'm not mistaken, but you can check that. End uses of solar power reported by SHS users, percentage of households reporting use. So for light, 100%. Fan, so Bangladesh is very hot and humid. Fan is a minimum item that one can use for cooling. It's not a luxury item like air conditioning, but obviously you can see hardly 21% are using solar energy for fans. TV, much higher. People of course need their entertainment, can't blame them. Radio, charger light, okay, and mobiles are more common than toilets in these regions, as we say, but mobiles are also very important for communication, for receiving early warnings, for watching out for disasters, and so on and so forth. Solar powered convenience store, barber shop, and electronics repair service from left to right. So you can see this cute wall mounting here in a kind of a building that's not as solid as the Oberlin, Ohio house, but it's an electronics repair service. If you live in these parts or in poorer parts of US, you know that you can always go and find somebody to fix your broken cell phone screen or keyboard and so on, where in many parts of the US you'll be forced to buy a new one and spend a lot more money. Distribution of cost, funding and financing of a 50 watt SHS. Note conversion rates used: $1 is 80 taka, the Bangladeshi currency. So we are looking here at a total cost of $407. So you have balance forwarded to households. So these are total cost to households at $422. Total interest to household is $56. Total grant given is $51, and the EU grant as percentage of household cost is 12%. So EU institutional development grant is $10, EU buy down grant is 10%, and balance forwarded to households here. And here household down payment $55, remaining balance financed is $311, and total interest at 6% flat over 3 years is $56. So this is the distribution of cost, funding and financing of a 50 watt SHS. People are convinced it will pay off, so obviously they will use the grant and loan mix to do this. So here is the willingness to purchase SHS system of different capacities under different price scenarios by households without solar power. So just asking people whether they would be willing to purchase. So here are the various power levels, 20 to 60, 20 to 85 watts current price, and 25% decrease. So would you invest if this was the current price and if the price was decreased? So percent of respondents willing to buy, obviously at the current price, is under 30%, but if you promise to decrease the price by 25%, it jumps to over 50% at 20 watts, and the numbers drop because the cost goes up as you go to higher wattage. So 40 watts smaller than 20 watts, 60 to 65, 80 to 85 smaller. But in each case, for whatever reason, the increase in numbers of people willing to purchase doesn't go up as much, even with the price drop here, but it jumps here again. So it must be somehow they are calculating the difference of the cost, and that's too high even if you decrease it by 25%. Okay. Sole share grid in marketplace in Bangladesh. You can see there is rooftops here, and the marketplace here with all kinds of shops, and you can see all the rooftops are dotted with these solar panels. Looking at Sri Lanka small tank cascade systems for building agricultural resilience in the dry zone. Key messages: small tank cascade systems in the dry zone of Sri Lanka harvest rainwater and mitigate floods and droughts. These are traditional systems of building farmer resilience to climate variability. Farmers have expressed willingness to pay to restore the degraded small tank cascades, and the government has identified restoration and sustainable management of STCS priorities, so small tank cascade systems, as a priority adaptation action in irrigation and agriculture. Okay, here is an example. Aerial view of Konakakumbekewa small tank in Kapirigemma small tank. So you can see how that works. Typical degraded small tank in a cascade. So you can see here there is a little well there which has got a pulley system as well as maybe a pump of some sort. We don't know for sure. You can read it if you want. Okay, so I'll leave this short podcast here. We'll come back and look at disaster risk reduction in the next podcast, and that's the fourth part here. We got another dozen or so chapters to go, and as you can see, I am being very brief, just reading key findings in most chapters. Obviously it's a long book, as I said. Books are published and lots of authors. I am not necessarily going to judge the book for its quality. I'm just taking the information and presenting it. To the extent that they are edited books and they've gone through some sort of a peer review, we can assume that they are vetted for accuracy and quality of science, quality of data, quality of presentations, analysis, and so on. But just take the main points, and if you want to really be strict about how good the book is, you can go and find out more about it, but it doesn't really take away from the messages that we are going to present here in terms of community resilience from these examples. Okay, so the idea is just to give you a sense of what research is done to quantify community resilience and how people adapt based on their empirical knowledge, practice knowledge, and various community-based adaptation attempts and various measures of success and so on, okay, for energy, agriculture, water, and so on.